Okay, as per our third semester syllabus, CHO 5301, we have finished almost all things from here. Only introduction for benzofuran has remaining this synthesis of some drug molecule. 2 3 remaining you can do by on yourself. Then from topic or paper number 5303, from here we have finished, or from first section, first chapter we have finished. And from section second, first chapter we have finished organic reaction mechanism and synthesis of and reactions of carbons and nitrates. Okay, so carbons and nitrates I have took introduction and some part of the synthesis. Reactions of carbons and nitrates, for that one I have provided you PDF file, so only questions will ask on the basis of those PDF files. Okay, so now we are going to start again the second chapter from the first section, organic stereochemistry. Stereochemistry of rings other than 6-membered rings. Okay, so it's a 7 lecture topic. We will start now that topic. Okay, so we have seen already, we have studied that all these 6-membered rings and its conformations, everything we have seen, its reactions, different reactions, how it undergoes reaction, and its stereochemistry. Okay, we'll see now the rings other than the 6-membered ring. Okay, so the classification of cycloalkanes we will see now here on the first slide. I have shown that classification of cycloalkanes according to number of cycles, how we can distribute that those cycloalkanes. Here monocyclics. Okay, so we know monocyclics here. Thus we I here is spelling mistake, s is extra here. So monocyclic compounds, spirocyclic compound, so one carbon atom is common to both ring, that one is the spirocyclic compound. What are the bicyclic compounds? In bicyclic compounds you can see 2 cycles they have fused. Okay, so those are the bicyclic compounds. Here you can see here bicyclic compounds. And bridged bicyclic, these are the bridged, this is bridge. Okay, in between 2 rings, this is bridged bicyclic compound. This is bicyclic compound, but this one is bridged bicyclic compound. Next one, it's a polycyclic compound. So polycyclic, you know, structures of steroids and all these things, such type of components, they comes under the polycyclic compound. So classification of cycloalkanes depends upon the number of carbon atoms in the cycle. Okay, small rings which contain cyclopropane and cyclobutane. Only 2 rings come under the small rings title. Common rings are cyclopentane and cyclohexane comes under the common rings. Okay, then medium sized ring. Okay, C7 to C12. Okay, carbon number size, cycloheptane to cyclododecane. Okay, up to that one it will come under the medium sized ring. And larger rings, how we can say larger rings means whose the cycle or cyclic system which contains more than 13 carbon atom, those comes under the larger ring compounds. Okay, so this is the classification of different cyclic systems which comes under this one. What are the sizes and everything. So up to now we have seen cyclohexane, we have seen chemistry regarding the cyclohexane. Okay, now we are going to see the chapter. The name of chapter is stereochemistry of rings other than the cyclohexane. So so for this one also we are going to refer the book Ilil, chapter number 9 from Ilil book, from the page number 248. It starts everything regarding the shape of rings other than 6-membered ones. Okay, so you can go through that book and you can refer that chapter number 9. So page range from 248 to 269. Okay, so this chapter comes under this the shape of rings other than six membered ones. Okay, so that covers everything. Shape of five membered ring, seven membered ring, eight membered ring. What reactions we those are included in under these sections. Everything they have covered in that chapter number 9. Okay, so we'll see one by one. Larger rings than six membered rings or smaller rings than six membered ring. All things I have written here. So cyclopropane, cyclobutane, cyclopentane, hexane, cycloheptane, and cyclooctane. So from cyclooctane, C8 to C12, it comes under the medium sized ring. Okay, cyclooctane to cyclo C12, it comes under the medium sized ring. Cyclopentane, cyclohexane, cycloheptane comes under the common rings. So conformation analysis can also be applied to ring structure. Ring structure can also have their own conformations. Okay, all these rings or they have their own conformations. In case of cyclohexane, we know that cyclohexane present in two different conformation, boat as well as chair conformation. Okay, this cyclohexane system exists in two different conformations. So same like cyclohexane, all these molecules, not cyclopentane, cyclobutane, but remaining more cycloheptane, cyclooctane, they do show some different conformations, and we will see the shapes of all those different conformations. Okay, the most common rings found in nature are five and six membered rings, most stable cycles. Five and six membered rings, you can find in nature. It's a plenty of structures you can find which contains five membered rings and six membered rings. Okay, so these are the most stable. These two forms, cyclopentane and cyclopentane, are more stable conformations or more stable forms compared to other cycloalkanes. Ring strain, so a lot of so many ring strain they do present in all these ring systems. Cyclohexane system is almost strain free. Later on we will see what types of strain present in different cycloalkanes. See here they have given in case of cyclopropane and cyclobutane, these two structures they are unstable because these two structures they have ring strain. Okay, so what is the ring strain? That means I think in the bond angle in between these two is 49.5 degrees centigrade. So maybe it's like that. We will see in detail in our next slides presentation. Five membered ring is quite stable like six membered ring. Okay, so these two are quite stable. That's why they do find in plenty of naturally occurring compounds. So cyclic alkanes and ring strain. Okay, so how cyclic alkanes they do affect by the ring strain. Chemists attributes much of the instability of other ring size to ring strain. The increase in energy due to the geometric constraints on the ring. Okay, ring strain can be quantified. Okay, so how to calculate the ring strain? How to say that okay, cyclopropane ring has this much ring strain? How to calculate cyclobutane's ring strain, cyclooctane, or like that? So we can calculate this ring strain in terms of heat of combustion. Okay, so ring strain can be quantified using heat of combustion, the energy given off in form of heat during a combustion reaction. That means if we will consume if you will heat